Namaskar. Let us continue in Python. In the previous sessions, we were going through the fundamentals of Python like variables. In fact, we learned how to open Colab notebook and how to get input and output statements in Python. Then basic numeric operations and then string operations we have seen. We have also gone through the if then else logic and then the for loop, which is a definitive loop, and then while loop. We will continue further in Python. I am going to add one more code section over here. In Python, so far we have dealt with numbers, strings. Now we are going to deal with two more stuff, which is again it's a kind of array but a list of elements. For example, if I say L is equal to and then within square brackets, I am going to add some elements. Okay, let us say Tamil Nadu, TN, AP, UP. I have to give the codes, MH. Right? This is, I have added a set of elements. Since I missed a quote, it is not coming in proper color. You can also see the color coding. I have defined a set of elements within square brackets. I assigned it a variable. Previously we used to say V1 is equal to 10, just one element to one variable. Now if you see here, there are 4 elements that I have assigned it to this one. Now if I simply say print L, and then I will also say print type of that variable. You know, we have seen integer, floating points, etc. Now let me execute this. Colab is now allocating a runtime machine. Now it is executing this particular section. You will see the output in a few seconds. Now if you see here, it is printing this as a list. It says the type is a list. So list meaning a set of elements that you have defined as a group. Okay, you can treat it as a string of arrays. One beauty with this is I can also assign number 2389.23. In the same list, I can have strings, I can have numbers, I can have floating points. It is not homogeneous, it is a heterogeneous array, I would say. Now if you see here, it is having that information. Now this whole code is a list operation. List is a specific data type. Now I am going to add one more code section. Now watch this. Previously I have added elements with square brackets. Now I am going to add something like this. T is equal to, rather than square bracket, regular bracket. Okay, just watch. I am going to print the same thing, print T, and then I am going to say print type of T. Okay, let us execute this particular code section. The effect is same, but only thing is it is saying the class type or the type of this variable is tuple. Both are a group of values stored in the same variable. You can store n number of elements in the tuple as well as list. In one case I am using square brackets, in another case I am using regular brackets. What is the difference? A tuple, you cannot change the elements. Okay, for example, in this list I am going to say L of 2 is equal to, I am going to say MP, okay, print L. Let us see how it works. When I print this, previously again in the arrays, the first element is 0, second element is 1, third element is 2. Now previously it was TN, AP, UP 0, 1, 2. Now I simply said L of 2 is equal to MP. I changed that element. Now I say print that whole list. Now you see instead of UP, the third 0, 1, 2, that element got changed. So in a list I am able to do that. Let me try to do the same thing here in a tuple. T of 1 is equal to HH, okay. Let me say print T. Let me try to execute this. When I try this, it is giving me an error. Tuple object does not support items assignment, because once I define that element, I am not able to change that. Same way in list, I can always say, the moment I say L dot, okay, you could see all the methods, what operations you can do on that list, it will list. Now I say L dot append, I am going to add last, okay. I am say print L. Let us see this. Previously it was having the last element as 89.23. Now the moment I say append, it is giving me that last element also added to that list. So in a list you can add elements, you can remove elements. For example, if I go here and then say L dot, there is a method called remove. You can reverse that. You can change the elements in a list. Whereas in a tuple, it serves the same purpose. It's an array. Array means a group of values stored in the same variable with the same name, but the values are different. In a tuple, you cannot change. We call it as immutable. Immutable meaning it cannot be changed. Once defined, it is there as is. You have to just use it. Where is the use? For example, in India, the list of states are predefined. So you can use wherever the state codes are fixed. Wherever the data doesn't change and the data set is limited, there you can use tuple. Where the people should not change the values, you can use tuple. Where the values can change, you can use lists. So these two elements, these are not singleton values, these are all multiple values. A group of values are stored in the same variable. There are other two elements also. There is something called a set. Pretty much like in mathematics, we used to say set A, set B, A union B, A intersection B. We can use set also here in Python. There is something called a dictionary. You can refer some element, it will return some element. That is also there. So tuple, list, dictionary, set, all are a group of values stored in a single variable. At this point of time, we are not going to get into dictionary and list. It is enough if we go through list and tuples. So you can refer to W3C schools or Python help to read further. Hope this concept is clear. Now let us do one more code section, okay. Let us have one more code section. Now we are going to see something called functions. In any language, a group of or a set of lines are going to be reused. Suppose I want to calculate area of a rectangle, right? Then the breadth into width. That's what we are going to see. The length into breadth, whatever you name it, LB. I want to pass multiple values, calculate it again and again and again. For that sake, we don't have to repeat the code. we can define it as a function, then we can reuse it in multiple ways. At multiple locations you can call that. That is called function or a procedure. For that, first you need to define the function. So the syntax is define, let us say, area of circle. Okay, I simply use the acronym AOFC as the function name. Define area of circle, and then I want to pass the parameter. What is the typical parameter that you want to use for a circle's area? All you need to know is radius. So I want to pass something called R. R is a placeholder. This is just a parameter. Right now R doesn't have a value. Now how do you calculate? I say area is equal to 22 by 7 star R star R, right? This is how you calculate the area. Now I say print area. So the function or the block has got two lines. For that you are passing a parameter. It is exactly like mathematical notation. Y is equal to f of x. You pass x, you calculate the value of y. In this case, the function name AOFC. Some people call it as a function, some people call it as a procedure. That's fine. There are some minor differences. We will come to that later. You need to pass parameters. Now, how will I get the values? For example, I say n is equal to, I am converting to integer, input of give radius. Okay. Now I am going to say call this function AOFC and then pass the value of n. Okay. Pass the value of n. To make it very clear, I will print it here. Print I am inside function. Okay. What happens is when the program sees a block, it doesn't execute immediately. When it comes here, it first executes this line because this is outside the function. It gets an input from the user. That input it passes to the function, then control goes here. These lines will get executed. Let us see how it works. I am going to execute. It is asking me give the radius. Now I say 5. I enter. It says the moment you pass this input 5, it goes inside the function. It prints I am inside the function. Then it is calculating the value of pi r squared, and then it is printing that value from the function. To make it very clear, I will also put one more line here. I am outside function. Let us execute it to make it clear to you. I am passing 5. The moment I type the 5, it goes inside the function. It is printing this line. It is calculating the value area. It is printing that area value. After finishing all the lines inside the function, it comes out and then starts executing the next statement in the main code. This is how functions work. Now, I can pass multiple parameters. It is not just one parameter. I am going to define another function. Define area of rectangle, right? For that, I need to pass L comma B. Two parameters I need to pass. As usual, you have to put the colon. That is to indicate that this is a block statement. Now I say print inside function. Now I am going to say area is equal to simply L into B, print area, correct? So I have defined two functions, one to calculate the area of circle, one to calculate the area of rectangle. Now I am going to say area of rectangle I am passing, the moment I put that bracket, it automatically knows there are two parameters you need to pass, L and B. Suppose I say 5 comma 4, right? Let us see what happens. Now let me run this code. This is for the circle. Now the moment the program reaches this line number 15, it is going to this function. It prints inside function statement. I passed 5 and 4. It does this one. 5 into 4 is equal to 20. It prints that value. I can reuse it again and again. Area of rectangle 7 comma 9. Pass this value. Let us execute this. Okay. Let me comment these two lines. Okay. These 3 lines let me comment. Now let me execute. First time it is calling this function with 5 and 4. Second time it is calling this function with 7 and 9. Now you get the value 63. All you need to do is, you don't have to copy paste that code everywhere wherever you need that calculation. Just call. This is called reusability. Define once, call it from anywhere you want with whatever parameters you need at that point of time. This will reduce the code size. Number of lines will become less. Code will become more compact. Code will become more modular. It is more logical to understand what the code does. It is like define the high level tasks, branch out from those high level tasks, then define the grassroots level tasks, execute that, then come back. So this definition of functions will help us to modularize the code, and maintenance of code will be much easier. Once again I repeat, when it comes to application programming like banking or insurance or textile industry or for stock market, you will write a lot of logic. Whereas when it comes to ML and AI, you will not be writing thousands of lines of code. To solve a particular problem, a few hundred lines, maybe even less than 100 lines will do the, because the focus here in ML and AI is to deal with more data than the logic, because the data is already fed, the data is already processed. There are multiple ways to clean the data, to massage the data, then to present the data, to analyze the data. You will be writing code only for that, but not to gather the data and validate the data. So the number of lines of code that you will be writing in ML and AI will be way less than what you do in systems programming as well as in applications programming. Hope this is clear. And there are libraries. I told about predefined libraries that many people in the open source community have done a lot of experiments, programs. They release those programs. It is all time tested. We don't have to recode those logic. You would have heard these phrases like reinventing the wheel. Reinventing the wheel means the invention of the wheel has made significant changes in the human evolution in terms of the scientific space. The science, along with math, the invention of zero, again the wheel, right? Again in science, invention of wheel, name it for the car. It has made a tremendous progress. It has given a great leap in terms of thinking and getting the job done in a much easier and efficient way. It is already invented. Why should we break our head again and again to reinvent that? Same way, many people in the open source community have already done this. It's all time tested. We don't have to waste the time. For example, I want to calculate average of some 100 numbers. I want to calculate the standard deviation of something. It is all already coded. I give 100 numbers, or I give n number of, let us say, I don't know what is the count. I will give you 7,000 or 8,000. 70% should be split into one part, another 30% should be split into another part. to split that into two parts. I don't have to write the code, it is already coded. All I need to do is just call that. For example, I give a set of numbers, you plot this as a line graph. Code is already done. All you need to do is a few lines of code, just consume that, pass these values. These are all called libraries. Some of the libraries are definitely two libraries that you will be using a lot. One is called NumPy. To get that library into your code, you need to use the word import. Import NumPy. Typically, we will also give an abbreviation or an acronym, okay? A short form. Rather than always calling as NumPy, NumPy is a predefined library which is already loaded into Colab environment. To get those things into your code, you need to use this word import. In C, you would have used a hash include. In some other languages, you would have used the word using that library, bring that into that reference to your code. This as NP means later on when you refer, you will use this short form NP. This is numerical Pythons. All numerical methods will be under NumPy. Okay. Now there is another famous library, matplotlib. As typically we use the 2-character or 3-character acronym or abbreviation or a short form. For plotting, because when you see the values as a stream of numbers, it is very difficult to understand what it is. Whereas when you see it as a graph, when you see it as a chart, when you plot it in a graph, you will get more information by visualizing the data. For that, we use something called matplotlib. This is also again within that pyplot. Okay, you can import the whole library, or within that library only a particular section, library dot that section alone, a set of procedures will come. Within NumPy also there are a lot of sections. Whichever section you want to import, you can say that library dot that section name will be very simple. So import, again import Seaborn, right? There are a lot of libraries like this. Again, most of the things that most of the times you always use is that these two libraries. The two libraries that you will always use are NumPy and matplotlib. This is the fundamental of Python. Python is ocean. You can do a whole lot of stuff. What we have done in this session is to give you a glimpse of what to do with Python. Okay? You may have to do a lot more exercises on these things. We will also publish these exercises, worked out examples in our learning management systems, so that you will get benefit of the solved examples. For example, print the Fibonacci series. You know what is Fibonacci series? Okay. Let us say first two numbers are 0 and 1. Assuming that the first two numbers are 0 and 1, the next number is the sum of the previous two numbers. 0 plus 1 is 1. The next number is sum of the previous two numbers. 1 plus 1, 2. Then 1 plus 2, 3. Then 3 plus 2, 5. Then 5 plus 3, 8. Then 8 plus 5, 13. So the series goes like this. If I change the first two numbers as 4 and 7, what is the next number? 11. What is the next number? 18. So first two numbers, the subsequent, you fix those two numbers. Subsequent number is the sum of the previous two numbers. This is called the Fibonacci series. Given the first two numbers as 8 and 4 and 8, find out the 15th number in this series. I want to write a program. For that, you may have to get the input from the user, you may have to calculate arithmetic, you may have to calculate, you have to do the loops, you may have to do some if conditions if needed, correct? So We will give a lot more small snippets of the codes with worked out examples as well as a few exercises for you to solve. This is fundamentals of Python. Once again I repeat, unlike applications programming for a business, when it comes to ML and AI, you will not be writing thousands of lines of code. A few lines of code will be very efficient to solve a math problem. With that, I will stop this particular session in Python. Thank you. Jai Hind.